Hi everyone, this is Yashvi Patel and you are watching my YouTube channel. So today we are gonna learn image thresholding. Image thresholding is a great way to extract useful information while minimizing the background noise. So you can see this is my original image, or after image thresholding we will get this type of image. So now you have an idea what image thresholding is. So there are two type of thresholding techniques we can use. One is simple thresholding and the second one is adaptive thresholding. So in simple thresholding, we assign some value x if pixel value is greater than threshold, else we will assign y. So to use simple thresholding, the function is cv2.threshold, where the first argument is our image, second argument is threshold, third argument is assigned value, and the fourth argument is cv2.thresh binary. There are five type of threshold type we can apply. First one is threshold binary. If the source pixel is greater than threshold, we will assign the max value, otherwise 0. And the threshold binary inverse is exact opposite. If source value is greater than threshold, we will assign 0, otherwise max value. And threshold truncate, we will assign threshold if source value greater than threshold, otherwise source will be as it is. And threshold to 0, we will not change source pixel value if source pixel is greater than threshold. If it's not, then we will assign it to 0. And threshold to 0 inverse is exact opposite of threshold 0. So I have here applied all this four threshold in this my image, and I'm showing you the plot of this. You can see the binary threshold, binary inverse threshold, truncate 20 and 20 inverse. So the main problem with simple threshold is we use global threshold value, but it is not convenient as image has different lighting condition in different areas. Second solution handle this scenario, which is adaptive thresholding. Adaptive thresholding decides how threshold value is calculated. It has two methods to calculate threshold value. The first one is adaptive threshold mean C, in which we calculate the mean of the neighborhood areas minus some constant C. And adaptive threshold Gaussian C, in which we calculate the Gaussian weighted sum of the neighborhood values minus some constant C. So you can see here I have read this image where the list of some objects, and I'm doing a median blur of this image, and I will explain all of this in my next videos. For now you just understand it's blurring my image. Then I applied simple threshold and adaptive threshold with adaptive threshold mean C, and adaptive threshold with adaptive threshold Gaussian C, and I have listed it the result here. You can see the global thresholding. It's not clear, but you can see the adaptive mean threshold is very much clear, and adaptive Gaussian thresholding. It's adaptive mean thresholding is darker, and adaptive Gaussian thresholding it's somewhat lighter. So you can see the difference of simple thresholding and adaptive thresholding. And you must be thinking there is some parameter in simple thresholding, this return parameter. What is this? So there's one concept in simple thresholding is O2SU binarization. Using O2SU's binarization, we find out that if our threshold value is right or not. Let's say you have a bimodal image. Bimodal image is an image where you have a two peaks of histogram. So O2SU binarization try to find the optimal value of the t which is in between those two peaks. So if we applied global thresholding and we did not apply the O2SU's binarization, the return value will be the threshold which we have applied. But if we apply OTSU's binarization, it will return some return variable which contains a threshold value. This is my original noisy image, and I have applied a global thresholding with threshold 127. If I apply OTSU thresholding in the original noisy image, it will not affect anything. If I will apply Gaussian filter, and then you can see my histogram look like this two pics. And if then I will apply OTSU's thresholding, my threshold image will look like this. You can see the difference after applying this. So let's see how it is implemented under the hood. So we try to find the t which lies between the two peaks such that the variances of the both classes are minimum. For example, here we try to find out this t where q1t, which is summation of all the pixels from 1 to t, and q2t is summation of all the pixels from t plus 1 to I. And we will find this weighted mean, which is IPI divided by q1t, and from this weighting mean we calculate its variance and put all of this in this equation and try to minimize this function and find out this t which minimize this function. So this t is our optimal threshold value. So this is it for today. If you like my video, then do not forget to like, share and subscribe my channel. Until then, bye bye.